Machine Pencil Cartography. The purpose of my channel is to teach my audience how to navigate in diverse geographical contexts. Today, I was inspired to discuss a few historical challenges that existed in maritime navigation, where sailors repeatedly experienced challenges related to their ships being piloted onto land. This often resulted in tragedies such as shipwrecks or loss of life, giving the sailors plenty of motivation to adapt to this unique navigational challenge. Today, I will report on the solutions that they found. At the center of our problem, we will need to examine the geographical setting where ships are most likely to run aground, and we will remember that this is a coastal plain. Therefore, we will be tasked with designing solutions that prevent ships from colliding with coastal plains. The solution to the problem of boats running aground is something that the sailors did not have to fend for themselves to resolve, because the governments of maritime countries around the world have also recognized this problem as legitimate. In many cases, the Coast Guard has volunteered to help solve this problem on the sailors' behalf. The Coast Guard has a division which holds this responsibility, and this division is known as the National Lighthouse Service. This is how the lighthouse accomplishes its mission to help sailors avoid running aground. First of all, most sailors will carry nautical charts with them while they are out at sea. In fact, this is a very common practice. These nautical charts are compiled statistical almanacs that will include whatever data a sailor might need. Nautical charts often include the depth soundings of the seafloor below the water, especially when you're sailing in shallow water. You will almost always find this data recorded in your nautical charts. A sailor will need to know the draft depth of their own ship, and the draft depth for each ship is different. Given a plotted map that displayed the depth of the sea floor for the surface of the coastline and the surrounding area, you can topographically imply what the safe standoff distance for your ship is, and then you have to stay at least that far away from the coastline. This is the exact physical explanation, and failing to keep a parallel index from the coastline from the prescribed distance, as it was determined by subtracting the nautical depth of the water from the draft depth of your ship, will absolutely result in tragedy or disaster. Thank you guys for listening. This has been Machine Pencil Cartography, signing out.